Hello guys, welcome to my channel. So today we are going to start the topic of redox reaction. It's an important chapter in chemistry. So let's start with the definition of redox reaction. What is a redox reaction? When oxidation, redox, when reduction and oxidation takes place simultaneously, then the reaction is called a redox reaction. It is a particular type of reaction. You know there are many types of reactions, displacement reactions, combination reaction, likewise double displacement reaction, precipitation reaction. Likewise, a category of reaction is known as redox reaction. In redox reaction, there are two major topics or two major keywords that are used everywhere in this chapter. These are oxidation and reduction. Oxidation and reduction. So first we are defining what is oxidation and what is reduction. You may all know, we have studied in smaller classes that oxidation is the addition of oxygen. See, oxidation, addition of oxygen. Reduction is the addition of hydrogen. So if you think, you can say oxidation is also removal of hydrogen and reduction is also addition of removal of oxygen. So oxidation is the addition of oxygen, reduction is the addition of hydrogen. Oxidation is the removal of hydrogen and reduction is the removal of oxygen. Also, oxidation can also be defined in terms of electropositive element and electronegative element. Oxidation is the addition of electronegative element and the removal of electropositive element. When an electronegative element is added, an electropositive element is removed. Therefore, oxidation, reduction, there are four definitions. You can tell me, first one is addition, let's define for oxidation, and for reduction that is just the opposite. Okay, so first let's just define oxidation. Oxidation is the addition of oxygen. Whenever oxygen is added to a chemical equation, it is oxidation reaction. Then oxidation is the removal of hydrogen. Oxidation is the addition of electronegative element and it is the removal of electropositive element. Just opposite for reduction. Reduction is the addition of hydrogen, removal of oxygen, addition of electropositive element and removal of electronegative element. Ta-da! Next, we have one more definition. That is the most important definition for oxidation and reduction. Oxidation is the loss of electron. Whenever electrons are lost, we will come to see how they are lost. It is oxidation. Whenever electrons are gained, it is reduction. That is simply oxidation and reduction, and it's a very important concept. It's called electronic concept of oxidation and reduction, and it's very important. So oxidation, what is oxidation is loss of electrons and reduction is gain of electrons. Next two keywords are oxidizing agent and reducing agent. So when oxidation and reduction takes place simultaneously, we get a redox reaction. And in a redox reaction, there should be an oxidizing agent as well as a reducing agent. Oxidizing agent is one that helps in oxidation, while reduction is one that helps in reducing agent is one that helps in reduction. Got it? Okay, so oxidizing agent means it helps in oxidation. So if a substance is helping in oxidation, it should undergo reduction. We will see the examples. When a substance is undergoing oxidation, it is called a reducing agent, because only when a substance is oxidizing itself, it can reduce the other substance, and therefore it is reducing agent. So when a substance is undergoing oxidation, it is a reducing agent, and when a substance is undergoing reduction, it is an oxidizing agent. So these are some confusing things, but it's a very simple. This is very simple. So now we are going to start with the oxidation number. Okay. Check out this reaction. This is Zn plus Cu2 plus gives Zn2 plus Cu2. Zn2 plus Cu. Zn is zinc, Cu is copper. Now, we can split this reaction. This is a redox reaction. Now we are going to prove how this is a redox reaction. First in our reactant sites we have zinc and copper ion. First we are taking zinc. Zinc should be converted into Zn2 plus. How? When Zn2 plus means it is losing 2 electrons, right? So zinc loses 2 electrons and becomes Zn2 plus. 2 electrons, it loses 2 electrons, forms Zn2 plus. Losing of electrons, what is the reaction called? Oxidation. Oxidation is the loss of electrons. So this is an oxidation reaction. Actually, this is called oxidation half reaction. half reaction. Because why it's half reaction? It's half reaction because this is a complete reaction. From this complete reaction we are taking a part. So this is oxidation half reaction. This is oxidation half reaction. Now what is the reduction half reaction? You can tell me. Cu2 plus. Cu2 plus should be converted into Cu. How we can convert Cu2 plus into Cu? See, Cu2 plus should gain 2 electrons and form Cu. So Cu2 plus gains 2 electrons and form Cu. That is what gaining of electrons? Reduction. So this is reduction half reaction. Oxidation half reaction and reduction half reaction. Next, now we are adding these two. We are arriving to this equation and we are proving that this is a redox reaction. Now when we add Zn plus Cu2 plus 2 electrons gives Zn2 plus Cu plus 2 electrons. Now we are cancelling out these 2 electrons and we get the equation. Now we prove that this is a redox reaction. This type of questions are very important in board exam point of view because these are mainly asked in board exams. Now we are arriving at an important topic that is very important in our mains point of view. That is oxidation state or oxidation number. Oxidation number or oxidation state. Actually in our redox reaction it's the most important concept. So the concept of oxidation number or oxidation state. Okay, there are some points that you need to by heart. After by hearting them, we will see the use of this oxidation number. Before that, let me show you an example to make it clear for you what is oxidizing agent and what is reducing agent. Let's take the earlier example itself. Zn plus Cu2 plus gives Zn2 plus Cu. Now here, which one is undergoing oxidation? Zn becomes Zn2 plus, Cu2 plus becomes Cu. Zn becomes Zn2 plus. What is this? This is loss of electrons, this is oxidation. Cu2 plus becomes Cu. This is gain of electrons, this is reduction. Now can you tell me which is, so we can from this it is clear that zinc is undergoing oxidation and copper is undergoing reduction. What is the reducing agent? Which is the reducing agent here? Reducing agent is one that undergoes oxidation or one that helps in reduction. Cu2 plus is undergoing reduction, and for Cu2 plus to undergo reduction, Zn must be present. So Zn is helping Cu2 plus to undergo reduction. So Zn is the reducing agent. Reducing agent is the one that helps, that promotes reduction. But Zn is undergoing oxidation. So reducing agent is one that undergoes oxidation. So our reducing agent is Zn and our oxidizing agent is Cu2 plus. We have to write the sign also, Cu2 plus. This is also an important question, that is determine which is the reducing agent and which is the oxidizing agent. Important question for boards, class 11 boards or school exam. Now coming back to our topic of oxidation number. Okay, first point you have to note. First point, there are several points. First point is for first group elements. There's group 1 in the periodic table, group 1, group 2, group 3. First group elements, oxidation number is +1. Second group oxidation number is +2. Aluminium oxidation number is +3. Halogen, second point. For halogens, oxidation number is, usual oxidation number is -1. Almost. But when a more electronegative element is present, for example, let's take an example of chlorine. But if chlorine and fluorine are present, in a compound, if chlorine and fluorine are present, chlorine has the oxidation number +1 and fluorine has the oxidation number -1. Well, you see, chlorine is also a halogen, fluorine is also a halogen. But Chlorine has -1. We have written that halogen has oxidation number -1. But here chlorine and fluorine are present, and we are giving chlorine the charge +1. Why is it so? That is because fluorine is more electronegative than chlorine. We already know that we have studied in the classification that fluorine is more electronegative. Fluorine is the most electronegative element. It has electronegativity 4 according to Pauling scale. So whenever the halogen atoms comes with a more electronegative element, it is having +1 oxidation state. Halogen usually have -1 oxidation state. Fluorine always fluorine have -1 oxidation state. Fluorine always have -1 oxidation state. Okay. Next, our third point. Third point is that hydrogen, oxidation state of hydrogen. Hydrogen has oxidation state +1. Hydrogen has oxidation state +1. But if it is present with a more electropositive element or less electronegative, see sodium hydride, which is more electronegative. Obviously, electropositive, which is more electropositive or less electronegative. Sodium is more electropositive, right? Electronegativity decreases down a group, so down a group electropositivity must increase. I don't know if there is a thing like that. Anyway, sodium has higher electropositivity than hydrogen. So sodium gets +1 oxidation state, and hydrogen gets -1 oxidation state. This is also an exception. See, hydrogen usually has the +1 oxidation state, but when a more electropositive element is present, hydrogen has negative oxidation state. Same like in the halogens usually have -1 oxidation state, but when it is present with a more electronegative element like fluorine, then it has +1 oxidation state. So those are the exceptions. The halogen exception is when more electronegative element is present, it has +1 oxidation state. Hydrogen exception is when more electropositive element is present, it has -1 oxidation state. Then for next is oxygen. Now we are discussing the case of oxygen. We are discussing the main elements. Okay, oxygen has oxidation state +2. Sorry, -2. Oxidation number we can also take it as oxidation state. It's usually both are used controversially. Now oxygen has the oxidation state -2, but in the presence of peroxides, when peroxides are present, it has -1. When superoxides are present, it has -half, and when more electronegative element is present, it has +1 or +2. See, this is a very important case of oxygen. Oxygen usually has -2 oxidation state. That is pakka. Next, -1. When does oxygen has -1? Oxygen has -1 in case of peroxides. See, in the case of H2O2, hydrogen has +1 oxidation state, and oxygen has -1 oxidation state. For peroxides, oxygen has -1 oxidation state. No other way. Oxygen has -1 oxidation state. That is pakka for what? Peroxides. For superoxides, for example, KO2, potassium has oxidation state +1. So oxygen should have an oxidation state -half. So we can say for peroxides, oxidation number of oxygen is -1. For superoxides, oxidation number of oxygen is -half. Now, if oxygen is present with the fluorine, OF2, oxygen is present with the fluorine. Oxygen has oxidation state +2, fluorine has oxidation state -1. See, now oxygen has oxidation state +2. See, this is the peculiarity of oxygen. This is the peculiarity of chemistry. There are so many exceptions, right? What to do? So oxygen and its cases, oxygen usually has -2 oxidation state, but when it is with the peroxide it has -1. When it is with the superoxide, it has superoxide. Okay, superoxide, it has -1/2. When it is with a more electronegative element, it has such as fluorine, it has +1/2, +1 and +2 positive oxidation state. Next, oxidation state of an element is 0. For example, Cl2. It's an element. Its oxidation state is 0. O2. It's an element. Its oxidation state is 0. Guarantee. Element oxidation state of an element is oxidation state is 0. Also for a compound, in a compound, for example NH3, for the whole compound, the sum of oxidation state should always be 0. This is an important point. It is used everywhere to calculate this oxidation number of unknown elements. Okay, so for neutral compounds, sum of oxidation state, let me tell you, sum of oxidation states of all elements is 1. Sum of oxidation is nitrogen. Here in this case, nitrogen has oxidation state. Actually, let me take another one. Here, we don't know, we cannot calculate the nitrogen's value just like this, right? Let's take H2O. H has positive +1, this -2. Sum of oxidation state is here, this is +2. Sum of oxidation state +2 +2 -2 equal to 0. This +1, it's coming 2 times, right? 2 times. So 1 into 2 minus 2, it's equal to 0. So for a compound, for a neutral compound, the sum of oxidation states is always equal to 0. For ions, oxidation state is equal to its charge. For ions, oxidation state equal to charge. For example, Al3+. What is oxidation state? +3. Next, for compounds which are ions, NH4 plus. How do you get? What is its peculiarity is that the sum of oxidation state will be equal to charge. Sum of oxidation state will be equal to charge. That is the oxidation state of N plus 4 into oxidation state of H will be equal to 1. +1 means +1 itself. So these are the basic rules of oxidation number. What was first rule? First rule states that for first group elements, oxidation state is +1. Second group oxidation state is +2. And for aluminum, oxidation state is +3. Then for halogens, it is -1. But when it is present with a more electronegative element, its oxidation state is +1 or it's positive. Then for fluorine always has oxidation state -1. It never has positive oxidation state. Why is that? That is because fluorine is most electronegative element according to Pauling scale. Next, that we learned about halogens. Then hydrogen. Hydrogen has oxidation state +1. But when it is present with a more electropositive element, for example, sodium hydride. Just think about the example of sodium hydride. Sodium has oxidation state of +1. Hydrogen has oxidation state -1. In such case, hydrogen should have oxidation state -1. Then oxygen. Oxygen is very peculiar case. Oxygen usually has oxidation state -2, but in the presence of peroxide it has oxidation state -1. In presence of superoxide it has oxidation state -1/2, and in the presence of more electronegative element it has positive oxidation states also. See, oxygen is a very versatile element. Then for a single element like chlorine, Cl2O2, oxidation state is 0. For a neutral compound, the sum of oxidation state of each element will be equal to 0. Like in case of NH3, we said sum of oxidation state of N plus 3 into oxidation state of H will always be equal to 0. Why we are adding into multiplying by 3? Because if not, it will not be correct. So we are always multiplying it with the 3. Then for compounds that are not neutral, sum of oxidation state will be equal to its charge. Then for ions like Al3+, charge oxidation state is same as charge itself. Okay, so this thus completed our part 1 of oxidation, part 1 of redox reactions. Here we defined oxidation, reduction, reducing agent and oxidizing agent, and finally we defined the redox reactions, and then we started a topic of oxidation number, oxidation state. It is very important, these points. I think there are, when we calculate it, there are 9 points, there are almost 9 points. These are very important points that you have to keep in mind while we are doing problems based on redox reaction. So see you in our next class. Hope you like this video. Please share and comment below. Thank you. Signing off.